Hello family, welcome back. My name is Victor Uribe and today I'm going to talk about the measures of central tendency and dispersion measures in less than 5 minutes. But Victor, this is impossible! Let's do it. First we are going to talk about measures of central tendency. These correspond to values that are generally located in the central part of a dataset which help us to summarize the information of a single number. Those are mean, median, and mode. Mean is the value obtained by dividing the sum of a conglomerate of numbers by the number of numbers. To clarify this definition, I have an example. Let's suppose that Cristiano Ronaldo played 3 games and in the first game he scored 2 goals, in the second 1 goal, and in the third 2 goals. He scored 5 goals in 3 games. Now we want to know his mean of goals per game, and we are going to divide his 5 goals between the 3 games that he played, and we obtain 1.66, which is a great percentage of goals. The median is a value that is in the middle of the other values. When we ordering the numbers from lowest to highest, it is right in the middle between those above it. To clarify this example, let's suppose that a family have 4 kids, one with 5 years, other with 7 years, other with 10 years, and other with 13 years. The median of the years of the kids is going to be the central values, which are 7 and 10. Those values are going to be added and then divided by 2, and in this case the result is going to be 8.5. Finally, the mode is the most repeated value, or the one with the highest frequency. To clarify this definition, let's suppose that we ask 7 kids their favorite flavor of ice cream, and they answer like in the way of the table in the screen, and we obtain that the mode of the flavor of ice cream is chocolate because 4 kids choose chocolate. Now we are going to talk about the dispersion measures. Those attempt through the calculation of different formulas to show a numerical value that provides information on the degree of variability of a variable. First, we are going to talk about the variance. It represents the variability of a data series with respect to its mean. Formally, it's calculated as the sum of the square residuals divided by the total of observations. To clarify the definition of the variance, I found an example in internet that refers to the weight of the people, and we are going to use ranges. The X means the marked class. This is going to be obtained adding the lowest and the highest levels or values of the range and divided by 2, and we obtain these values and the frequency. Then we are going to multiply x by f, and we are going to divide by the total number of frequency, which are 15, and we are going to obtain the mean of the ranges. That is going to be very important to obtain the variance. Once we have the mean, which in this case is 54.33, we are going to do a subtraction of the marked class minus the mean, and we are going to power to the square. Then we have these results, and we are going to multiply by the frequency of each range, and then we are going to add all the final column. We are going to add all the values, and we obtain this value, which is 493.33, and we divide by the total frequency, which is 15, and we obtain the variance, which in this case is 32.89. Now, talking about the typical deviation, it provides information on the dispersion with respect to the mean. Its calculation is exactly the same as the variance, but by taking the square root of each result. In this case, we are going to use the same example because we already calculate the variance. So to calculate the typical deviation, we only are going to use the square root of the variance that we obtained before, which is 32.89. We obtain the square root and we have the result is 5.73. This is the typical deviation of this problem. Finally, we are going to talk about the coefficient of variation. It tells us about the relative dispersion of a data set. Its calculation is obtained by dividing the standard deviation that we have by the absolute value of the mean of the set that also we have, and is usually expressed as a percentage for a better understanding. To understand better this part, I'm going to use the same example because we have the mean, which is 54.33, and the typical deviation, which is 5.73. We have those, and these are going to be important to the coefficient of variation. We divide the typical deviation between the mean, which in this case, and then we are going to multiply by 100, and in this case the result is going to be 10.55%. and this is very interesting because if we have like a less percentage, we are going to have like more precision in our data, but if we have a higher percentage, we are going to have less precision in our data. Well, family, we didn't do it in less than 5 minutes, but we tried. I hope that you enjoyed this video, that you learned something new. Thanks for watching, and I hope that you have a nice week.